Right, so now we've had a look at the basic rules. We're going to have a look at some really advanced, really cool little things. So I'm going to put up a couple of different ones and we're going to try them. Okay, so the first one we're going to have a look at is this one. X squared y to the minus 3 over x to the minus 4 y to the power of 5, and the whole thing we're going to put it to the power of a half. And what we're going to do here is we're going to simplify it. We're going to use our indices rules to simplify it. So there's lots of ways at going at this. Okay, so I would always try and do what's inside the bracket first before I try and deal with what's outside the bracket. So let's see what's happening in here. We have a base number over a base number, and both those base numbers are the same. So we can use our division rule. So 2 subtract negative 4. So 2 subtract negative 4 is 6. Okay? Now, let's see what we have here. We have minus 3 subtract plus 5. So that's minus 3 minus 5. That's minus 8. And then we still have our half out here. So now we're going to distribute our half in. Now, what's our rule here? Well, look, we've got an indice in a bracket. So I can distribute the indice over both of them, or I can just hit them both at the same time. It really doesn't matter. But I'll distribute it over both of them. So that's really x to the power of 6 to the power of a half multiplied by y to the power of minus 8 to the power of a half. So let's do the rule. We've got our bracket rule. So we're going to multiply 6 by a half and we get 3. And we've got our bracket rule here, minus 8 times a half, and we've got minus 4. Okay, so that's your answer. However, because there's an indice rule here, we have to do that indice rule. So that's going to be x cubed over minus means fraction. So there you have it. That's the first one done. Okay, so let's have a look at another one. Square root of a cubed over the fourth root of a multiplied by the cubed root of a squared. Okay, so when I see this, I see loads of roots. So that's my first job. Let's unroot things, for want of a better word. So what did this used to be? Well, there's no number out here. So if there's no number out here, the number out here has to be 2, because it's the lowest root is the square root. So our rule says this used to be the top of the fraction, this used to be the bottom. So that's a3 over 2. Now, what did this used to be? Well, the 4 used to be the bottom of the fraction, and there's no number here, so we assume that's a 1. So that's a to the power of a quarter. And then same thing here, a to the power, top of the fraction, bottom of the fraction, a to the power 2 over 3. Now, I see two brackets beside each other, so that means add a to the power 3 over 2 over 2/3 and a quarter. Well, let's get that going here. 2 over 3 plus a quarter is 11 over 12. And now I see 1.5 subtract 11 over 12. Why? Because that's the division rule. So let's do that one. So that is going to be minus 5, and it's going to be positive. So it's 7 over 12. Okay, now if you want to turn that back into what it used to look like, well, it used to look like this. The 12th root of a to the power 7. Okay, so I'm going to do another one for you. Let's have a look at this one. Let's go. 5 to the power of n plus 1 minus 4 times 5 to the power of n over 5 to the power of n minus 2 plus 5 to the power of n. And we're going to simplify this. So let's have a look at this one. This is unusual. Okay, we haven't seen this before. So let's see what had to happen to this indice in order to get a plus between the two parts of the indice. Well, if you think about it, we have a rule that allows us to add. So that used to be 5 to the power of n multiplied by 5 to the power of 1 minus 4 times 5 to the power of n, all over, same thing on the bottom, 5 to the power of n by 5 to the power minus 2 plus 5 to the power of n. So now you see I've got everything in base 5 apart